In this video, we're going to discuss the use of lists as stacks and queues. Now, Python does not include separate implementations of stacks and queues. However, it is possible to use lists to represent both of these data structures. Although using a list as a queue is not the most efficient means of doing so, but we're going to discuss that momentarily. If I wanted to use a list as a stack, where a stack is defined to be a last in, first out data structure, we could use the append and pop methods from list to do this. So for example, if we had a list named stack, and we initialized it with the elements 3, 4, and 5, we could push the items 6 and 7 onto the stack using the append method from list. And so if I output this stack, you'll see that we have 3, 4, 5, and 6 and 7 are at the end. And so in this case, the right side of the list will be the top of our stack. And so if we wanted to remove elements from our stack, we can use the pop function and actually remove several elements from the stack. And each call to pop will actually return the top of the stack at that point. So the third instance here returns 5, having already popped 7 and 6 with the previous two calls. And if I output the stack here, you see that we have only the elements 3 and 4 remaining. So with these two functions, you can see that the list object can be used as a stack, and so there's no need to have a separate data structure just to implement stacks. Now, we can similarly do this to emulate the functionality of a queue, which is a first in, first out data structure. However, while popping the last element from a list is fast, popping the first element is not, since that operation requires us to actually shift all the other elements in the list down by one position. But to show you how this could be done, let's go ahead and create a name. We'll call this our inefficient queue, and we'll initialize it to have elements 3, 4, and 5. And then just like with stack, if we wish to push elements into our queue, we're going to use the append function. And so I'll push elements 6 and 7 onto the end of our queue, and then we'll just output our queue. And so now the right side of this list is the end of the queue. So this is where the items are being inserted or pushed onto the queue. And the left side of the list represents the head of the queue. So since this is a first in, first out data structure, we're removing items from the left. So we'll use the pop function again for this. But this time we're going to specify that we're popping the element at index 0, so the leftmost element in our queue. And just like our previous example, we'll pop the first 3 elements off the queue and then print it back out. And you'll see that the remaining elements in our queue are 6 and 7 here. Now, a more efficient solution is to actually not use a list for a queue and instead use a deck from the collections module. A deck is similar to a queue, but can have elements added or removed from either end of the deck. And the collections deck object was designed specifically for these operations to be fast and efficient. So if we want to use a deck, we have to import it from collections. So here we have from collections, import deck, and then we can initialize it with a list if we want. So we're going to bind our deck to the name queue, since that's our intended use. And once again, we can use the append functions to add items to our queue. And then to actually pop an item off the head of the queue, we'll use the pop left method, which will efficiently remove items from the front of our queue. So if we run this block, we'll see that the return value of pop left is the first element that was removed from the queue, which is Eric. If we run the next block, we'll see that John is now removed from the queue. And finally, if we output the queue itself, you'll see that the remaining elements are Michael, Terry, and Graham.